Welcome back to Solving Problems Together, and today we'll dive straight into a geometry-based problem. We've been asked to find how many different isosceles triangles we can find that have a difference of 36 degrees between the unequal angles. So how might we get started with this? Well, firstly, let's just remember an isosceles triangle, just as the image I've put on the screen, has a pair of equal sized angles. And then the third angle within that triangle is not the same as that pair. An isosceles triangle also has a pair of equal length sides, but I don't think we'll need that for this problem, not just yet anyway. So my initial thoughts are that we're going to be working with the angles in a triangle, particularly the sum of the angles in a triangle. We know that the angles should sum to 180 degrees. I'm going to make use of algebraic expressions since we don't know the size of the angles, but I can make an expression to show that difference of 36. And that should lead to an algebraic equation which we can solve. Solving that equation with a little bit of substitution should let us determine the exact angle sizes within those triangles. So here's the first triangle that I'm going to think of. I'm going to call these base angles x. So each of these two are x, unknown angle size, but I'm going to make the top angle 36 degrees larger. There's a difference of 36 degrees between the equal angles and the solo angle. In this case, I've made the top angle larger than the others. How about if those were the larger angles, and I made the top one the smaller of the angles? Well, in this triangle, the top angle is x, and the pair of angles, the equal angles, are x plus 36. They're larger than the solo angle. Okay, so I think these are the two cases. Either the pair are larger in size, or the solo angle is larger in size. I did think I might have other triangles where I had x and x minus 36. In that case, x would have been the larger and x minus 36 would have been the smaller. But that's actually equivalent to one of the two that I have on the screen right now. Okay, let's set up some equations. So, in this first one, adding together all three of the angles, and we can put them equal to 180. If we tidy that up, we get 3x plus 36 equals 180, and solving for x equals 44. In the second case, adding together, we actually get 5 terms from adding these angles together, and tidying up, we get 3x plus 72 equals 180. Solving, we get x equals 36. Two different x values. X actually represented something different in each of those diagrams, so let's just be careful with what we do with these x values. So let's just substitute them into each of their respective triangles, and this is what we get. These two triangles. These are the two isosceles triangles that have a difference of 36 degrees between unequal angles. A quick sense check, I would just double check that each of my triangles do actually add up to 180. And they do, so that's an indication that we've gone down the right path. So as usual, if you had any alternate approaches to solving this problem, or if you can think of any way to make it a bit more interesting, challenging, or just take it further, we'll be happy to hear about those in the comments. Really looking forward to you getting the conversation started. Come back again soon so we can solve another problem together.